everyone, this is a continuation video of this lesson 4.1 work. Specifically, we'll be focusing on force distance graphs. Work is the area under the curve or under graph of a force distance graph. So therefore, if you have a graph of force against the distance, the area under that graph would be the work. So let's take example number 5. A car's motor applies a varying force as the car travels along a highway. Use the table of values to calculate the work done by the motor. So if I'm gonna graph this one, I'm gonna place my force along my y-axis, and then I use the increment of 150, and I have distance as, or maybe I can just use another color for that. Distance is along my x-axis. Okay, so if I gonna plot this one out, I have 0 0, then 100 150, and then 200 300. At 300 meters you have 300 newtons. 400 meters you have 300 newtons. Then at 500 meters you have 600 newtons. And then at 600 meters you have 900 newtons. And at 700 meters you have 1200 newtons. And then at 800 meters you have at 800 you have 600 newtons. So my graph would look like this. It goes up, this, and then goes up and down. So work done here is given by the area under the curve. So the area under the graph would give me the work. So this is the work done by the motor. So the area of this. So when we talk about kinematics, we also talk about area under the curves, right? So in this case, if you're graphing force against the distance or the displacement, the area would give you the work. So all we need to do is compute the area of this. Well, this is a composite figure. Just like before, we can break this one down into different areas of particular shape. So I call this one A1. So that's a triangle. And then this one here is a rectangle. And if you can see here, this can be broken down into this whole thing here. This is 700. So I can have, this is area 2, this is area 3, this could be my area 4, this could be my area 5, right? And then this is my area 6. So you can also uh, have your own partition if you want, but in my case I created 6 different areas, so of particular shapes. So again, I know the area of a triangle and the area of a rectangle, so that's why I try to make them into triangles and rectangles. So A1 is just a triangle, and getting the area that is just 1/2 of the base. The base is 200, and then the height is 300. So that gives me 30,000 joules. Again, this is uh, Newton and meter, so that gives me joules. And then we have the second part, that is a rectangle. So base is 200 times the height of 300. So that gives me 0.00006. So that would be 60,000 joules. The third partition is again a rectangle. So the base is 1, 2, 3. That's 300. And then the height is 300. So that gives me 90,000 joules. Okay, and then we have A4. A4 is a triangle. Actually, if you can see, that's a right triangle. So the area is just 1/2 times the base is 1, 2, 3. It's 300, and then the height is from 3 to the tip of 1002. That would be 900. Okay, so again, the base is 300, so from 400 to 700, that's 300, and then the height is from 300 to 1200, so that would be 900. So that would be 100,035 joules. 135,000 joules. Then A5 is a triangle again, and the area is 1/2. Base is 100, and then the height is 600. So that gives me 30,000 joules. Then lastly, the partition 6, that's a rectangle with a base of 100 and the height is 600. So that gives you 60,000 joules. So now the work done here, the work is just the sum of everything. So I'll just take the sum of all of the areas, and that should give me the my work. So that's 30,000 plus 60,000 plus 90,000 plus 135,000 plus 30,000 plus 60,000. So that gives me 405,000 joules. Okay, so that's the work done by the motor. So I will assign you example number 6 and number 7 as your assignment. So again, same thing, you try to answer this one And here, if you're able to write it here, or you can also write your answer in a separate sheet of paper. And please do show your work, show your solution. So that's all for lesson 4.1, and see you next